Okay, so good morning, everyone. Today we are going to learn about Chapter 9, Quantitative Statistic, which is related to Section B, Group Discrete Data. I think you know the meaning of discrete data. I already explained you in the previous sections. I hope you understand the meaning of that. And for today, we are going to learn how to group the data, how to group the discrete data, and along with how to plot data by using stem and leaf plot. Okay, the key term for today is about the class interval. You have to understand what is the meaning of the class interval, stem and leaf plot, or we can say stem plot. These are the two keywords that you have to understand the meaning of that. Okay, without further delays, let's go to the explanation here. For example, in the situation where there are large number of different data values, it is not sensible to organize the data in a frequency table. It is also often inappropriate to display the data by dot plots or column graph. For example, a local kindergarten was concerned about the number of vehicles passing between 8:45 a.m. and 9 a.m. over 30 consecutive weeks they record the data. Okay, so these are the result of the data that they record about the number of vehicle passing the local kindergartens between 8:45 and 9 a.m. So the result was here, yeah. How many day totally 30 day, right? So here would be 30. Yeah, I think one row should be 15. Okay, and when you look at the data here, you can see that what is the smallest values of the data and what is the higher values of the data. So in this data, if we look through that, we have 40 is a bit higher, and the smaller would be here, it's 18 something. Yeah, but the second row, if you look at here, we have 52, which is higher than 40s. Yeah, and also we have 9 here, which is the smallest one. So we can say that the smaller values of this data is 9 and the highest values of this data is 52. So imagine if you draw like a bar graph or a dot plot. So imagine that how many bar you need in order to plot that graph. From 9 to 52, I think it's more than 30 bar. It's more than 30 bar that you need in order to plot the bar graph. So to avoid using many bar like that, then we have to group those data into the interval. So in this situation like this, it is appropriate to group the data into class interval. And in this case, we use class interval of the length 10. So the class interval of the length 10, so you can start from 0 to 9 is considered as one interval. The second class interval is from 10 to 19. The third from 20 to 29. The fourth class interval from 30 to 39 and so on. So that, and then you count the frequency in each of the interval. For example, from 0 to 9, how many frequency here? You can see there's only one here, so the frequency is 1. From 10 to 19, Okay, let's count from 10 to 19. This 1, 13 is 1, 18 is 2, 16 is 3, 18 here is 4. Okay, anything else? So it's 4, but here it's 5. So I think I missed somewhere. Okay, let's count. Oh, 17 here, 1, 13, 2, um, 18 is 3, 16 is 4, and the last one is 18 here is 5. And so on. If you count the frequency, it should be something like the number here. Okay, so this is called the group discrete data. Group discrete data, you can see something like this. And in other words, you can use stem and leaf plot in order to display this graph. So display this data, for example here, stem and leaf. Remember that a stem and leaf plot or stem plot is is a way of recording the data in group. It is used for small data set. So in here we have only 30 data set, so it's small. But if we have more like 100 or 1,000 data set, so it will be inappropriate to use stem and leaf. So remember that stem and leaf is only for a small data set. It's so that the actual data values and give a visual comparison of the frequency for the number of two digits. The first digit from part of the stem and the second digit form a leaf. So the first here is represent for the first digit and this is for the second digits. For example, for the data values 18, so 18, the 10 digit is 1 and the second digit, which is called the 1 digit, is 8. So 1 is recorded on the stem and 8 is recorded on the leaf. So this for example 09 here, it means that 9 years. Yeah, this is 9 here. We can represent as on stem and leaf here is 09 here. And for example like 23 here, 23 here, if you write in stem and leaf, 2 is here and 3 here. So 2 and 3 here, it's mean 23. So the order of stem and leaf plots arrange all data from the smallest to the largest. Okay, so this is the stem and leaf data which is not arranged in order. You can see that here we have 9 here, it's 1. And after that 10 here, we have 17, 13, 18, 16 and 18 here. So totally 5. And after that 27, 23, 28, 24, 23, 22, 29, 24, 24, and 24 here. So totally we have 9 frequency, 10 frequency here. Yeah, something like this. And this is the stem and leaf that the stem and leaf plot that we do not arrange it in order yet. But this one is the order stem and leaf plot. It means that this stem and leaf plot is already arranged in order. So as you can see here, here we move where is the smallest number for the 10 digits here. 3 is the smallest one, and after that 6 and 7 and 8, 8. So here we arrange in order 3, 6, 7 and 8, 8, something like this. So this is the notice for the stem and leaf plots. All the actual data is shown. The minimum or smallest data values is 9. You can see here, and maybe you also can find the greatest values of data is 52 here, or the maximum values is 52, and the 20s interval occur most often. It means that it has the most frequencies. Here's the 20 interval. This is the 20 interval. Right. So I hope you understand the meaning of the group discrete data. When do we use the group data, and you also understand how to plot the data within you by using stem and leaf plot. So I hope you understand those two things. I think that's all for today's lesson, and this is your classwork. After watching this video, so you can do this classwork. Okay, so thank you everyone. See you next week. Bye bye.